Okay, next we're going to speak about dynamic ARP inspection. It's going to be a feature to prevent or defend against some ARP attacks. Now, ARP is normally a request reply protocol, which you know that ARP performs IP to MAC resolution. So I want to speak on an IP address in the same VLAN, but I don't know the MAC address of that destination. I'm going to send an ARP request saying what is the MAC address of that IP address of 1234. And I got to receive a reply saying from 1234 saying, here we go, my MAC address is whatever the MAC address is. Now I also have something in ARP which is called a GARP or gratuitous ARP, which is an unsolicited ARP reply, which is per ARP design. It's a legitimate use, so there's nothing like an attack. GARP, the GARP is not an attack. GARP is a legitimate ARP reply, an ARP type of packet, which is used to refresh a neighbor's ARP cache. But the illegitimate use of GARP is to spoof someone else's MAC address. So you're gonna see the ARP spoofing attacks makes use of the GARP functionality. And by doing this kind of attack, the attacker can succeed again a man-in-the-middle attack for the data plane traffic. And the attack relies on the fact that ARP request and GARP are broadcast packets, and it makes sense. That's by design. So looking in here at our diagram, for example, when PCA, which is an IP address of .100, wants to speak with router 1, which is .1, it's going to send an ARP request, which is broadcast, saying ARP request, which is a broadcast message. It's a broadcast message saying what is the MAC address? What is the MAC address of 10.10.11.1? And while I'm explaining this in there, I want you to tell me, it's a very simple RNS question, routing and switching question. Why can't the switch forward a broadcast message specifically out on a port, and it has to flood it out on all ports? So why can't the switch forward a broadcast message out on a specific port? And so that's the ARP request. The switch receives it. It sends it out on all VLANs, on all ports which are in forwarding state STPYs of that VLAN. Router 1 receives it. And router 1 is going to send a ARP reply, which is going to be a unicast packet, saying that the IP of 10.10.11.1 has a MAC address of A, or whatever the MAC address of router 1 is. And that message goes to PCA only because it's going to be a unicast packet. Now, what GARP is, and GARP is useful. It is by design because, for example, if PCA, so initially the MAC of router 1, the MAC address of router 1, initially, the MAC address of router 1 was A. So PCA had an IP, an ARP entry which stated IP of 10.10.11.1, which is router 1, is reachable at the MAC address of A. It has done this ARP entry via ARP request reply. But then if for whatever reason router 1 fails, where I have to replace router 1, so I replace router 1 because it failed with a new router, which means this MAC address changes now to B. If PCA is going to continue sending traffic to get out of the VLAN, and at layer 2 destined to the MAC of A, nobody's going to accept that packet because nobody owns that MAC address anymore in the segment. So for that reason, what router 1 is going to do when I replace router 1, or when a router shows up in a network and an interface comes up, that's by design. So when the router enables an interface which has an IP enabled, and also in other cases, but this is the most commonly used one, router 1 is going to send a GARP message which is a broadcast message because router 1 needs to make sure that that message reaches out all hosts in that VLAN. And the guard message says you find the IP address of 10.10.11.1, which is myself, to the MAC address of B, let's say. And then PCA is going to receive that information and change over that entry saying, oh, so IP 10.10.11.1 is reachable to MAC address of B. Oh, this is by design. But now what can happen, how an attacker can influence that, is that let's say that router 1's MAC address is A. I'm going to use the color of, let's say, black. So router 1's MAC address is A, the legitimate one. And PCA's MAC address is B. What this means is that PCA has an ARP entry. PCA has an ARP entry which states that the IP of 10.10.11.1 is reachable at the MAC address of A. And router 1 has an ARP entry which states that the IP of 10.10.11.100, which is PCA's IP address, is reachable at the MAC address of B. And now the attacker shows up in the network. And the attacker is going to send two GARP messages, which GARP messages are going to be broadcast. He's going to send two GARP messages, one GARP message saying, and the attacker's MAC address is, let's say, a MAC of C. Attacker has a MAC address of C. He's going to send a GARP message out in the network saying the IP address of 10.10.11.1, which is router 1's IP, is reachable at a MAC address of C, which is the attacker's MAC address. And another GARP message saying the IP address of PCA is reachable likewise at the MAC address of C. Which what this means that when PCA receives, this is the first GARP message and this is the second GARP message. When PCA receives the first GARP message, it's going to refresh the entry saying, oh, so 10.10.11 is reachable of MAC address C. PCA is going to believe that, oh, somebody replaced the router, so that's the new MAC address of my default gateway. When the second GARP message is received by router 1 says, okay, so somebody replaced the NIC card of that PC, so the new MAC address of that PC is C. So what this means that now when PCA and router 1 want to speak to each other, they're actually going to send the packets via the attacker. Because when PCA wants to send packets to router 1, at layer 2 is going to send a destination MAC of C. And the switch is going to forward that over to the attacker. And the attacker, of course, is going to relay that packet out in the network if it's smart enough, but of course it's going to capture the traffic from PCA. Likewise, when router 1 wants to speak with PCA, because now router 1 believes that PCA's MAC address is C, he's going to likewise send a packet, believe it's going to go to PCA, but destination MAC of C, which means the switch is going to forward it to the attacker. And again, if the attacker is smart enough, he's going to relay the packet back in the network with a proper destination MAC address. But again, the problem is that the attacker has a copy of the traffic flowing in the VLAN. Of course, another kind of attack would be that when the attacker, so the MAC address of router 1 is, let's say, as I stated, A, the MAC address is A, and the PC's address is B, and the attacker's MAC address is, let's say, the attacker's MAC address is likewise C, but then the attacker sends GARP message in the network like this. He states that PCA, which is 10.10.11.100, is reachable of a MAC address at the MAC address of D, which nobody owns in the network. Likewise, 10.10.11.1, which is the default gateway, is reachable at the MAC address of E, which nobody owns in the network. So at this point, what's going to happen is that all hosts are going to now consider that the default gateway is reachable at the MAC address of E, and because nobody owns that MAC in the network, the PCs become isolated. They cannot send traffic out of that VLAN. So it's another variation of the same attack with different outcome. Now, mitigation. To mitigate the ARP attacks, solution is to implement dynamic ARP inspection, or DI. Now, like as the feature is available only for IPv4 traffic, because IPv4 uses ARP to do IP to MAC resolution. IPv6 uses ICMPv6 packet types to do MAC to IP binding. It's likewise the layer 2 switch capability enabled per VLAN, just like HTTP snooping. And by the name, the switch is now going to intercept or inspect ARP packets. And just like in the case of snooping, once you enable dynamic ARP inspection on a VLAN, all ports in that VLAN become untrusted from the ARP point of view. The outcome is that the switch is going to intercept in order to validate all ARP packets on untrusted ports for validation. So just like snooping was, the HTTP snooping was intercepting all the HTTP packets received on untrusted ports, and snooping was dropping server time messages. What ARP is going to do, ARP inspection is going to do, is going to intercept all ARP packets received on untrusted ports to validate them, to prevent those kinds of attacks from for spoofed ARP packets from an attacker. Let's see how that validation is being done. So the switch performs ARP packet validation in the following order. So once I want to enable dynamic ARP inspection in this VLAN, dynamic ARP inspection, likewise all ports in that VLAN are going to be untrusted from the dynamic ARP inspection point of view. So now when a switch receives an ARP packet inbound on any of those two ports, and doesn't matter the ARP packet type, receives an ARP packet on those untrusted ports, what the switch is going to do is it's first going to check the IP to MAC binding from the ARP packet against a statically configured ARP access list. You would configure this, of course, you configure a static IP to MAC binding as a static ACL for statically assigned addresses in that VLAN, like the default gateway. If it fails to validate against that static ARP entry, the received ARP packet is going to then look at in the DHCP snooping binding table to see in there if the ARP packet which the switch has received on an untrusted port matches an entry from the snooping binding table. And this is useful for DHCP assigned addresses in that VLAN. If it fails to validate the ARP packets following the above steps, the ARP packet is being dropped, is considered to be spoofed. So if we follow up on the same example as before, and let's also put the attacker in there. So what I'm going to be doing is as follows. So let's consider, like I said, that the MAC address of router 1 is A, the MAC address of PCA is B, and the MAC address of the attacker is C. And the IP address of the attacker, let's say, is .90 in that subnet. So what I do is I enable dynamic ARP inspection in VLAN 11. And because router 1, which is what that means is that these two ports in here, actually by default all ports, are going to be untrusted. So are going to be untrusted from the ARP inspection point of view. which means all incoming ARP packets on those ports have to be validated by the switch. So now, what I'm going to do in the end to make this work, to prevent the attack, and of course to also allow ARP to work back and forward, is that because for PCA, the switch is going to know how to validate PCA's ARP packets. Because when PCA has sent initially a DHCP discovery message, and it was assigned an address via the DHCP offer message, the switch has built that DHCP snooping binding table. So the switch has in the binding table, the switch has from the DHCP snooping binding table the fact that the MAC address of B, which is PC's MAC address, that MAC address was listed an IP address of 10.10.11, an IP address of 10.10.11.100. And this is a mapping from V911 on port FA105. So when PCA sends any kind of ARP packets saying, for example, I am the IP of 10.10.11, I am the IP of 10.10.11.100, with a MAC of B, the switch receives it inbound on an untrusted port, is going to validate that entry against the DHCP snooping entry. So the switch is going to accept the ARP packets received from PCA. It knows it's going to validate the ARP packets from PCA, the payload of the ARP packet, against the DHCP snooping entry. But now if router 1 is going to send an ARP packet, which is the default gateway, saying I am router 1's MAC to IP binding, then switch 1 is not going to find an information in the binding table because router 1 has a static address. So for router 1, for the switch to accept our packets inbound from router 1, we have two options. One, which is not recommended clearly, we make this port a dynamic ARP inspection trusted port, which, just like in the case of DHCP snooping, the switch is not going to perform any validation of our packets received inbound on a trusted port because it's trusted. So why am I saying this isn't not a good thing to do design-wise? Is because somebody, of course, could come in on that switch port and actually put itself in there. An attacker can connect itself in there instead of router 1. So this can become an attacker. So the attacker can actually remove router 1 from that port and put itself in there, which basically is going to be bad. So what I'm going to be doing is that for router 1, I'm going to go on switch 1 and configure a static ARP ACL, which I'm going to state in there on router 1. I'm going to state in that static ARP ACL that the IP of router 1, which is 10.10.11.1, is reachable at the MAC address of A. So for hosts which are statically assigned in the network, you're going to ideally configure a static ARP ACL, because in general, you don't have a lot of those hosts. In general, you're going to have pretty much the default gateway, and that's it, with a static IP address in there. So you go in and configure a static ARP ACL for the default gateway, saying what is the IP to MAC binding of the default gateway. So then when router 1 sends an ARP packet saying I am router 1, the IP to MAC binding, switch 1 is going to go on and validate that against the static ARP ACL. And because it's going to match, it's going to accept that ARP request and send it in the network. But then now when the attacker comes in and sends a GARP request, which it was before, saying that the IP of 10.10.11.1, which is the IP address of the default gateway, is reachable at the MAC address of C or D or whatever, and sends that guard message in the network. The switch receives it in an untrusted port. It's going to try to validate that ARP message first against the static ARP entry. It's not going to find such a static ARP entry with 10.10.10.11.1 mapped to the MAC of C. It's going to then try to validate that ARP packet against the DHCP snooping table, which is not going to find anything, which means validation fails and switch 1 drops that ARP packet. So that's how we prevent the attacker to send spoofed ARP packets in the network. So configuration-wise, we enable dynamic ARP inspection for the required VLAN. Ideally, DHCP snooping is enabled and functional, because otherwise it doesn't make sense to enable this feature, because it means that you're going to either go and configure all ports as trusted, which means you achieve nothing, because if you make the ports to be trusted, the switch does not validate ARP packets on the trusted ports, or you're going to have to put a static ARP entry in an ACL for all hosts in the network. So it's clearly too much overhead management wise. So this capability works, of course, good in networks where on VLANs where users are connected with devices are being assigned addresses via DHCP, which nowadays, given the mobility part, is pretty much everybody uses DHCP in general. So it's no longer a good thing to use static addresses back and forth on users' devices. Of course, on servers, it's a different discussion. Either way, so enable dynamic ARP inspection for the required VLAN. And then for the statically assigned IP addresses in the VLAN, like the default gateway, as I said, we have two options. We either configure a static ARP ACL, where we configure a static binding for the default gateway's IP to MAC binding, or we configure the port facing that device, the default gateway, to be dynamic ARP inspected trusted. Because dynamic ARP inspection does not inspect ARP packets on trusted ports, just like DHCP snooping was not inspecting DHCP packets on trusted ports. So ideally, you're going to use the first option, because the second option is not really secure. Optionally, you rate limit the number of ARP packets on untrusted ports. By default, the switch allows, there is a default, it allows 15 packets per second, ARP packets. If limit is exceeded, just like in the case of snooping, the port goes into error disabled state. And we spoke about how to recover ports from error disabled state in the port security. Video, where we stated that to recover the port from error disabled state, you either do a manual shut no shut, or you enable the recovery feature, the error disabled recovery capability for that specific cause that a port went to error disabled state. Verification wise, we verify the configuration. Show IP ARP inspection is pretty self-explanatory, because I'm configuring ARP inspection, so there you go, the command, and because it's for IPv4, it's the show IP command. Or show IP ARP inspection VLAN, if you have it for multiple VLANs, for which VLAN. You verify interface state and rate limiting with show IP ARP inspection interfaces. And you verify statistics about ARP packets being dropped or forwarded, just like in the case of DHCP snooping with show IP ARP inspection statistics.